Starting with example 16-17, if you remember, we did solve this example when we were discussing the velocity analysis, और हमने इसको solve करके ये जो ओमेगास दोनों 10 रेडियंस पर सेकंड निकले में, ये हमने velocity analysis को परफॉर्म करके ये दोनों ओमेगास निकाले थे. Do you remember that?
Yes.
Yes.
So since omegas are known to us, so we can directly start the acceleration analysis rather than first performing the velocity analysis. क्योंकि omega known है, हम acceleration से ही start कर सकते हैं. Okay, now in order to perform the acceleration analysis, we are going to start our solution from the point where the motion is known to us. So since the motion of this collar is known to us, so we are going to start with collar C. This collar is moving downward at a speed of 2 meters per second and an acceleration of 1 meter per second square. So we can write the vector AC as minus 1j meter per second square. ठीक है? Acceleration of point C हमें known है. So we have written that acceleration vector as shown to you here. Okay, then we are going to move. Sorry. We are going to move towards link CB, which is in general plane motion. So considering the next link, which is link CB, what should be the base point for relative acceleration equation?
C.
C. So the equation would become absolute acceleration of B to be equal to absolute acceleration of C plus alpha cross R, where alpha represents the angular acceleration of this link BC and R represents the relative position of B with respect to C minus omega square R BC, and this omega is going to be the angular velocity of this link, which is CB. So ये हमारे पास equation बन जाएगी. Okay, now in this case, the acceleration of point C is known to us, so we can write it as minus 1j. And as we have discussed earlier as well, that you cannot judge the direction of alpha, so you are going to assume it as alpha BCK cross RBC. What is the relative position of B with respect to C? It is going to be this vector, which has positive x, negative y. So 0.2 I minus 0.2 j. ये आपके पास alpha cross R आ जाएगा, minus omega square, so minus 10 square into 0.2 I minus 0.2 j. ये आपके पास complete equation बन जाएगी. Once you solve it, the right hand side would become minus 1j. जहां तक ताल्लुक इस अल्फा क्रॉस आर का है, तो अगर हम फर्स्ट टर्म की बात करें, इट इज गोइंग टू बी 0.2 अल्फा BC k क्रॉस I इज j, तो दिस वुड बिकम j और ये पॉजिटिव साइन आएगा. सेकंड केस में आपका ये नेगेटिव साइन है, 0.2 अल्फा BC and k cross j would become minus I, so this would become plus I. And further ये right side पे जो टर्म है 100, 10 square आपका 100 आ जाएगा multiply by 0.2, so it is going to be minus 20 I plus 20 j. ठीक है, let me call it as equation number 1, and this represents the acceleration of point B. Clear है यहाँ तक?
Yes, sir.
Okay, now moving on to the next link, which is link AB. So in order to apply the acceleration equation, first of all, what type of motion this link AB is undergoing?
Pure rotation about A.
So, pure rotation about point A. So if we want to write the acceleration of point B with respect to this link AB, what should be the equation?
Sir, alpha cross R minus omega square R.
So it is alpha cross R minus omega square R, but here alpha is going to be alpha AB, R is going to be the absolute position vector RB, omega is going to be the angular velocity of this link AB, and R is going to be the absolute position vector. Okay, so can you again judge alpha AB?
No, sir.
So you are going to assume it as alpha ABK cross RB. What is RB here?
Minus 0.2 J.
So minus 0.2 J minus 10 square minus 0.2 J, and further solving it आपके पास जो further solution आएगा alpha cross R minus 0.2 alpha AB, K cross J is basically minus I, so it would become positive. So 0.2 alpha ABI, ये आपके पास एक टर्म हो जाएगी, and the second term would be minus minus plus हो जाएगा 10 square which is 100 into 0.2, so 20 J आपके पास आ जाएगा, so plus 20 J. So let me call it as equation number 2. ठीक है, तो ये आपके पास दो equations आ गई हैं. Since it is a vector equation and both of them represents the absolute velocity of B, so comparing 1 and 2 and then comparing the coefficients on both sides of this equation, if you compare the I coefficient, it would be 0.2 alpha AB should be equal to 0.2 alpha BC minus 20. Once you compare the J coefficients, it means that 20, which is on the left hand side with J, would be equal to minus 1 plus 0.2 alpha BC plus 20. So how many unknowns are there in these two equations, 3 or 4? में कितने unknowns हैं?
Sir, two unknowns.
We have two unknowns, the angular accelerations of length AB and length BC. So once you solve these two equations, you are going to get alpha BC to be equal to 5 radians per second square and alpha AB to be equal to minus 95 radians per second square. What does that negative sign with alpha AB represents?
Our assumed direction was incorrect.
Yeah, so we assumed initially alpha AB to be in a counterclockwise direction. This negative sign indicates that alpha AB is in fact in a clockwise direction. However, alpha BC comes out to be positive, which means that our assumption is correct, and alpha BC is basically along the counterclockwise direction. Is it clear to all of you?
Yes, sir.
Any query which you want to ask regarding example 16-17?